Fnirsi sent me this power supply to take a look at. So take a look at, I will. So this thing is supposed to be pretty fancy. And if you don't know who Fnirsi is, Fnirsi, it's spelled like that, is a company that makes inexpensive test gear. And their stuff used to be like very inexpensive, as in like sort of like starter gear. But they're starting to level their stuff up quite a bit. And I think this product is sort of one of the things that they're going for here for higher quality. So we've got a couple of croc clip to 4mm bananas. They're not as fancy as the ones you can make yourself, but it is what it is. We've got a USB-C to USB-A cable. And then the unit itself. So already, this is metal. So if this is anodized aluminum, that is a step to making a higher quality feeling item that doesn't have to be taken. So already this is not the Fnirsi that I knew from years ago. And what do we got? So that is the front of it. And so this is like, I mean, I've got pretty big hands. It's kind of compact. This screen apparently tilts. Oh, it does. Okay, I thought it would tilt more than that, but it does tilt. Good to see. We've got nice clicky knob. Oh, the buttons are not complete mush. They feel pretty good. This, I don't know what that is. Run, stop, and then, yeah, not too bad. Now, I guess I was hoping the screen would angle more than this, because like from the top down, you guys barely can see that at all. So that's a little interesting. So here is the side. These are vents. You can see right through them at an angle. This is interesting. There's glass or plastic on these holes. Here's vents as well. You can see a big coil in there. Let's flip this around the other way. Same thing. Glass or plastic. Can't really make up my mind. I don't know. Could be glass. These vents, yeah, as well. If you look down the barrel, you can see. Fan in the back. Power switch. USB. This must be for data. This does connect to your computer. Does this come out anymore? I don't want to force it. I really wish this would tilt up a little bit more for my specific use case. This tilt angle is really more of a gimmick, it seems. All right, so I guess I'll set up the camera a little bit better, and then we'll plug this in and see what it looks like. So I got you set up at a weird angle here, but let's just see if this is intuitive to use right out of the box. I did not read the manual. I shouldn't have to read the manual for a power supply. Here we go. Keep in mind the screen brightness will be a little bit dim to you. That's because I've got my studio lights here. Just want to make sure we are properly focused. And okay, first things first. The first things I noticed is that this screen, it does not angle that much. I think I would probably forego the tilt feature because it doesn't move a lot. So I know they like to call this a feature, but the fact that it doesn't move that much, I think it doesn't make much difference. Plus, the viewing angles are incredibly good. I am like right up on this, and I can see, I'm like looking at essentially this angle. I'm looking like down, like sort of this angle, and I can see it perfectly well. I don't think the tilt was necessary. If they really want to keep the tilt, I would make it tilt way more than that. It's just not enough. Either that or have the screen come out in tilt, sort of like cameras do, but whatever. Let's see if we can sort of figure out how it works. So this is not a button, that's just a light. And let's see, if we move a dial, oh, we're changing the display style. What if I click? Nope, changing the display style, okay. So how do I select volts or amps? Okay, I see there, the little selection. I can turn the little wheel here. So essentially you have to navigate using these buttons, and then you can change the voltage like this. I really don't like the beeping noise on any of my devices. Let's see, can we just tap? Don't think it's a touch screen. Okay, so let's see if we can adjust this. There should be a menu. Here's a little gear. So we've got data sets, okay. System. Brightness control 100%. We wish it was a little bit brighter. It's not bad. It's just a little dim underneath the studio lighting here. Volume control. Yeah, let's get out of there. Gone. Thank you. It's really nice that you have the option to bring it up or down, but I want it off. Metering switch close, device address, and style switch dark or light mode. Oh, that's cool. You can have a dark mode or light mode. Dark mode superiority, obviously. So you get back out the gear. There you go. And then you've got the about, and then you've got your data set. So how do we get out of there? That's not too bad. Okay. So if I want to set the voltage now, so let's say I want to set 15 volts at half an amp. Let's see, VA, okay, immediately on the V set. So 15 volts, that's good. That's not exit. I wish this was like confirm. So exit, oh, no. So 15 volts. And then at half an amp, let's move here. 4, 5, and then this to exit. Okay, that to exit. And then you can run it. Then the output is on. Nice big green LED when the output is on, so that's good. Then you have your 2 banana plugs here. They're not the style with the little, with little knobs that you can just shove a wire through. So that's a little unfortunate too, but it does keep this a little bit lower profile. But you do have a knob, so it's not that low profile. Just going to do a quick voltage accuracy test. I've got a Torch DL24, I believe, is the electronic load, just off to the side. And then I've got the connections going up to my Uni-T UT8805e multimeter. So we're going to check the open circuit voltage, or sorry, the no load voltage. And then we're going to check the voltage with about 5 amps of current on it. These test leads definitely leave something to be desired. They have very nice clips at the end, but I'm not convinced they're going to be able to handle the current very well. I think there's going to be a little bit of voltage drop, but let's give it a shot anyways. So if we run this, so there it is on. So 1 volt, and the Uni-T is reporting 0.99841. or so. It is fluctuating around there. Now let's turn on the load. So that is a 5 amp load. We are pulling 3.8 amps. So these two agree, and the voltage has dropped to 0.831-ish. So we are seeing a severe voltage drop at already only 4 amps, mind you, low voltage. So let's go ahead and turn that off. We're going to turn the voltage up. Going to go 2.5, like so. And 2.5 is showing 2.4982 volts. Let's turn on the load. This is pulling exactly 5 amps. This is showing, it's fluctuating around that same range. And the voltage drop is apparent now. We've got 2.28 volts at the end. So this could be a problem for you. If you're using these power supply leads, you are going to have a voltage drop through the leads. So you may have to supply your own for a 5 amp draw. Let's try this again. We're going up now to 5 volts. And 5 volts reading almost exactly 5 volts. And we're going to turn on the load. We've got a 5 amp draw. This is agreeing almost exactly back and forth. And now we have a voltage drop of about 0.3 volts. So this is much more acceptable. So as we get to the higher voltages, the voltage drop is getting a little bit better, which is normal. So let's go up here to 10 volts. And no load, 10 volts is reading almost exactly 10 volts. And then we're going to turn on the 5 amp draw. And these two agree almost exactly in terms of current, but we have a voltage drop 0.3 volts through those leads. Let's go up another time, 24 volts. And the multimeter has now switched positions. We've got 24.004. And we're going to turn on the load. We have almost exactly the same current draw on both of these, but now we have 23.789. So again, we are losing about 1/3 of a volt through these cables. So take that for what it will. I'm going up one last time here to its maximum of 36 volts. And we are reading nearly exactly 36 volts. And then if I turn on the load, pulling 5 amps, and again, we are losing about 0.2, 0.3 volts through the cables. Let's reset with some thicker leads and see what we get. Just for testing's sake, we'll have the same 36 volts output here and the same 1/2 amp on the Fnirsi, but now I'm using my custom-made, homemade 12 gauge wires. These should have a little bit less voltage drop, and we'll see that if it's true. So I got to turn it on, and no, we have virtually the same voltage drop. Now that's interesting. Let's go down to 1 volt and see if we get roughly the same as well. So there's 1 volt. So at lower voltages, it suffers a lot less than these guys, but at higher voltages, they're about the same. That's interesting. So switching the display, you can see the volts here. I don't really see a way to adjust sort of the height. Maybe it auto adjusts. If I turn on the load, there's the current in blue. So you've got the volts in yellow, current in blue, and you can see that. And let's see how fast it responds. Yeah, it's pretty quick. The only thing is the display is a little small, right? I think I would like to be able to zoom in to this, right? I'm tempted to zoom in like a scope you would do with a scope. So let's change the volts here. I can dynamically change it. So here's like 27 volts. Yeah, it's not something that you'll be able to see overshoot or anything on, but certainly something that you can work with. And then if I change the display, there's also this one. I'm not sure what this is telling me. This is like a battery charge or something. Because right now the output is on, but it's not doing anything. I accidentally found out what this screen does just by looking at the specs online. So I've got a USB tester here, and you can see that says A, and there's a USB-A port here. Oh. So I'm pulling 1 amp out of this, so it shows 1 amp right there. And then I can swap this to 2 amps. And it can provide the full 2 amps. And it can actually do a whole bunch of different protocols. We're going to have to test that another day when I get my protocols all figured out. But here we go, USB-C. We're going to try with this adapter. It is not a high quality adapter. I will say that right off the bat. So, oh, there we go. It's all the way in. So here we go. We're pulling 1 amp like so. And then we're going to flip this to 2. And we are pulling 2 amps like so through this poor little adapter, which I'm pretty sure is going to catch fire if I give it enough time. So then what's the verdict on this power supply? Well, I have to say, if you are looking for something and you don't mind waiting for sales, this goes down to an absolutely ridiculous cheap level. You can buy this right now on Fnirsi's site on the date of this filming for 200 Canadian dollars. So that is everything you need. That includes these leads that I would probably be okay with starting with, but would upgrade as soon as you can into something a little bit beefier. But other than that, this is a fantastic unit that if I had this around, I don't think I would have bought those read-ins that you see in the background because they require an external AC to DC converter. This one has it all built in, has nice aluminum finish. It has decent ergonomics. I will say the read-in is better with the keypad on it. But for the price, I don't think this thing can be beat. I think this thing can power your Arduino-y and Maker-y type projects for pretty much everything you need, except for when you need a negative rail. So go ahead in the links in the description. If you want to buy one of these and support the channel, go right ahead. If not, at least go check out the specs online and see if it's for you. When you guys click links like that, it tells the manufacturers that they should be sending more stuff over for review. And speaking of review, this is just a first look. So if you have any other tests you want me to do to power supplies, let me know in the comments below because a full review might just be coming if I get enough use out of this. Thanks for watching. Oh, that's the output. Ah, that makes a lot of sense. So this screen, which you guys can't really see, but it's this screen. That one shows you the protocol and the current draw and stuff from the USB.